Hey guys, welcome back to Crick Code. Today we're doing another Brainstellar Quant puzzle. This one is called e to the power pi or pi to the power e. Basically, we have to find which one is greater. Is it this or this, right? Without actually calculating the numerical values. But by that I mean like don't use a calculator. Don't try to like take the value for e as 2.7 and the value of pi as 3.14 and try to calculate what's the value for 2.7 to the power of 3.14, something like that. We have to find it using pure math, basically. And just to give you guys a heads up, this is by no means an easy problem. In my opinion, this one is pretty tough and it includes a bit of advanced math, which you don't usually see for easy quant puzzles. Having said that, this is a pretty famous quant puzzle. It says on the Brainstellar website itself that it is often asked in interviews, and it's somewhat beneficial to just kind of memorize the trick that is used in the problem. So, just to give you guys a few hints, one thing I could do is tell you guys the answer, and then you can still try to figure out how that one is indeed greater. That is a good sub hint, I would say. Well, the answer is e to the power pi. This is greater than pi to the power e. So I've looked up quite a few ways to solve this problem, and I found that the two methods that have been mentioned on the website for Brainstellar are, in my opinion, the most intuitive and easiest of solutions. So I'll be going over both of them. The first method actually includes expansions, the one that is used in the problem, and I guess it's kind of obvious once you start thinking about expansions, but the one used is e to the power x. And so the expansion for this e to the power x is this, right? The trick over here is to just consider 1 plus x and compare it. And so we know that e of x is always going to be less than 1 plus x, right? And now try to think of a value for x which would help us come to this kind of relation. And with a bit of thinking, it might start to become obvious that x should be put as pi by e minus 1. Now, what happens here? As soon as you plug in this value, everything boils down real quick. So you soon realize that this is how it ends up looking like, and you prove that e to the power pi is indeed the greater one. It's greater than pi to the power e. So the trick over here was to use this expansion of 1 plus x squared, 1 2 factorial plus so on and so forth, and to just consider these two values, because if you start taking x squared, then you can't really end up with over here, since there's no squares or anything like that over here. And you're using e of x because e of pi is pretty similar, right? I guess those are the intuitions for this. And plugging in x as this value is also kind of smart because you have to get rid of the 1. So yeah, so this is the first method. Coming to the second method, and the second method is what I would advise you guys to like memorize for further interview problems. So just to build a bit of intuition towards the second method. So since we've given the relation e to the power p and pi to the power e, I mean, so since I'm using this symbol over here because we don't really know whether it's greater than or less than, so we're just using a template for now. The trick is, well, since if we were to take both of them power to 1 by pi times e, the relation in between would remain the same, since both of them are, since powering to this value doesn't change the relation between them. So this is the official website solution, and we'll be walking through this solution only since my solution is the exact same as the one given here. I'll be explaining each and every step. So we start off with this initial problem, we convert it to this, and seeing this, we can define this function over here. So now basically what we have to do is compare f of x for value of e and value of pi, where f of x is x to the power 1 by x. So basically we have to find out whether this function over here is increasing or decreasing around these values, right? So one common way to do this, one common way to find out whether a function is increasing or decreasing is to take the derivative. This is a pretty fundamental calculus problem, right? Now, the thing is, the derivative of this function in itself is pretty difficult. So that we take this workaround where we create a new function called ln of f of x, right? Which would be, because of the value of f of x being x to the power 1 by x, g of x would eventually look like this. Now, why do we do this first of all? Now, if I calculate the derivative of g of x and figure out that, let's say, g of x is indeed increasing in the domain we are concerned with, well, since the ln function or the natural log function is a monotonic transformation, and by that I mean that if the value inside is increasing, then the function in itself will also be increasing. If the value inside is decreasing, then the overall function itself will also be decreasing. So if we can just try to find out whether this entire function is decreasing or increasing, we can comment about whether the inside function is increasing or decreasing, right? Because it's going to be the same. Right? We can deduce that x would be a global maxima for this function, because as we could see over here for g dash of x, so for g dash of x, we can see that the denominator is always positive and the numerator goes from positive to negative over the value x equals to e. So this entire derivative goes from positive to negative over the value x equals to e. So that also means that f of x, that f dash of x, would also go from positive to negative over the value x equals to e. All of this basically just means that e is a global maxima. So this is the plot for the function, and pi would be somewhere over here, which would be less than the value for e, right? And also the website says that it's pretty beneficial to memorize this, so I recommend you guys going over this once. I hope you guys understood the solution. It's completely fine if you didn't really get it in your first go, or you didn't come up with it yourself. This is that type of problem where it's much better to just memorize and learn from it. Thanks for watching.